Hello everyone, so today I'll be covering question number 39 of GATE 2006. Carryover factor CAB for the beam shown in the figure below is. So here's a beam which is given to us. There's an internal hinge at this point. These two lengths are L and L. So we need to find what is the carryover factor for this beam. So 4 options are given to us and it's a 2-mark question. The relevant NPTEL reference is given here. Let's see first what is a carryover factor. So a carryover factor is defined as the ratio of carryover moment to the applied moment. Let's consider this beam, simply supported beam. Let's call this two ends A and B. Let's M be the applied moment. So carryover moment is the moment which is carried over to the far end. So let's say this carryover moment is M dash, but in this case this end B is hinged, therefore it is not restrained against rotation, therefore this moment M dash will be 0 here. So carryover factor for this simply supported beam will be carryover moment is 0 divided by the applied moment M. CAB for the simply supported beam will be 0. So this is the basic concept of carryover moment. Carryover factor is defined as carryover moment divided by the applied moment. Now we'll see how to find the solution for our problem. So in this problem, let's call this end as A and this end as B. There's an internal hinge. This length is L and this length is also L. So let's M be the applied moment and M dash be the carryover moment. So here we need to calculate the value of this M dash and finally calculate the value of CAB, that is the carryover factor. Let's first calculate the reactions. Let us call this reaction at A is RA. So we know that at C there is an internal hinge, so moment at C is 0. From that we can calculate the value of RA as RA into this length L plus this moment M equal to 0. From here we can get the value of RA as minus M by L. So we have now got the value of this RA, which is minus M by L, so I'm drawing it downwards. Okay, now to calculate the value of M dash, let us make the free body diagram of this beam. Let's draw the part AC first. And this is part CB. Now we know that here it is M by L. We also know that the moment here is M, right? Now we are balancing first the vertical equilibrium, so this point will also be M by L but in upward direction. The moment at C is 0 because these two forces are trying to rotate this part, that is part AC, in anti-clockwise direction, and this M is in clockwise direction, therefore it is balancing it, and hence there is no moment at this point C. Now we will draw the free body diagram for part BC. Here it is in upward direction M by L, therefore for this point C it will be downward M by L. Now at point B, since this load M by L is in downward direction, therefore it will be in upward direction to satisfy the vertical equilibrium. Now the main thing, that is what is the moment here. These two M by L forms a couple and they are trying to rotate this part CB in anti-clockwise direction, and the moment is m by L multiplied by this length L. So the total moment with which they are trying to rotate this part is m by L multiplied by L, which comes out to be m. Therefore, to balance it, we have to apply a clockwise moment here, and the value of this clockwise moment will be m by L multiplied by L. M by L multiplied by L, that is m. So we have got a value of m dash as m. So we have got a value of m dash as m here. Now what is carryover factor? Carryover factor CAB is the applied moment divided carryover moment divided by the applied moment. The carryover moment is m dash and the applied moment is m. We have just now calculated the value of m dash as m. So the value of CAB is m by m, that is 1. So we have got the value of carryover factor, and it is 1. So from the options, the correct answer is option number D, that is 1.